Our work is on the neuroscience of fatigue. We all have some experience of fatigue. For example, after you go for a long run, you might feel fatigued. But disease-related fatigue is different. People with disease-associated fatigue will say they feel tired even when they're resting. And when they try to exert themselves, they feel exhausted. They'll agree with the statement, "I feel tired for no reason." Fatigue is associated with poor sleep, but it can be distinguished from the sense of sleepiness. This subjective sense of weariness and low energy has a huge impact on somebody's quality of life and ability to function. Fatigue is common following some viral infections, and it's associated with some therapies, such as chemotherapy. It's also common in many neurological disorders and cancer, for example, Parkinson's disease and multiple sclerosis. Fatigue is also common with traumatic brain injury and inflammatory disorders, such as rheumatoid arthritis. More than 1/3 of the United States workforce has experienced fatigue lasting longer than 2 weeks. With moderate fatigue, people come to work, but they're less productive. Severe fatigue, people find they have to stop working. It's estimated that fatigue costs U.S. employers more than $100 billion a year. There are few, if any, treatments for fatigue. This is a surprisingly understudied area of research. We have almost no understanding of the underlying biology that leads to the experience of fatigue. In my lab, we've developed a way to induce disease-associated fatigue in laboratory mice, and this allows us to study the underlying biology of fatigue. We've been able to examine the brains of these mice to determine where in the brain cells change activity when the animal is experiencing fatigue. We've been able to study mice missing one key brain signal, orexin, that was previously thought to be very important in the experience of fatigue. In our studies, we've been able to show that orexin is not necessary for the experience of fatigue in the laboratory mouse. Beyond studies of the brain, we're also testing new treatments. It's our hope that we will develop new therapies that will one day be used in the clinic to offer treatments for people suffering from fatigue. Our work with mice arose from one key observation. Across all the disorders that are associated with fatigue, a common element is inflammation. Inflammation in the brain causes fatigue. So in our laboratory mice, we treat them with a chemical signal of inflammation, interleukin-1 beta. When the animals are treated with interleukin-1 beta in the brain, they show the experience of fatigue through their decreased use of the running wheels. Many times a person who's suffering from fatigue will not even mention this to their doctor. They feel hopeless and feel like there's no treatments available. We hope to change that with our work. We will develop a better understanding of the underlying biology of fatigue, and we'll use this to develop better therapies and new treatments that can be used to help people suffering from fatigue.